Alright, let's go ahead and go through this problem. We are supposed to find the vertical asymptotes and then make a sketch of it. Alright, so I noticed that this is to the third power, and half of 3 is 1.5. So I can't factor it yet with binomials times binomials. So I recognize in this problem they both have a x as the greatest common factor. Raise your hand if you recognize that the GCF in this problem was x. Okay, so again, you look at the highest power, you take half of that. What's half of 3? 25. Is that 1.5 over here? No, so you can't get binomial times a binomial. But if you broke them into factors, you would recognize that they both have an x in common. Right? If you distribute x to the third, negative 16x. In the denominator, half of 2 is 1, so that can factor into a trinomial. What are my two numbers? 5 and 2. Which one has to be negative? Negative 5 and a positive 2. Negative 5 times 2 gives you negative 10. And if you add those together, you get negative 3. Now we just did a problem earlier. This will factor to be what? X plus 4, x minus 4. Raise your hand if you got that. And then I just have the x minus 5, x plus 2. Okay. Class, is there anything that we can cancel? No. So it's pretty busy. Now I'm just going to set those not equal to 0. So you're recognizing that you need factoring as a strong skill. X minus 5 is not equal to 0. X plus 2 is not equal to 0. And then when you solve that, you'll get x is not equal to 5. And you get x is not equal to negative 2. Raise your hand if you got that. Alright, so we're going to graph x equals, not equals 5. So I've got an asymptote way out there. I meant to do a dotted line. Negative 2. And I got this crazy looking graph. Crazy like my students who don't study for a test, you know? That's true, mister. There should be something on that side. So I have my calculator here. I'm a little suspicious. I should have something because I can put in, like, say, x equals 10. And I should get some values here. Does that make sense? So let's change my window. Let's increase my max to 20. Count by 5s. Let's see what happens. Hey, what happened? Let's try 30. Increase my, I didn't think it was there, about negative 20, 20, and count by 5s. Ah, did you see it? Oh. Something way up there, counting by 5s. So it might look something like this. Do you guys see that? I recognize that I have to have a graph on the outside of the asymptotes, inside, and to the far right. I know that I can have something to the far right because I can put second calculate, and I want to calculate an x value like 50, like way over here, right? Uh-oh. That means I picked the wrong number. 45. and you'll notice that you can actually get values way out there, right? That's the big idea.